I sent you guys via Classroom yesterday an email that I received from the College Board talking about what happens if you need to submit your exam and something happens and you can't submit. Then the instructions are posted there. I think there will be more instructions on test day, but basically there is an email option to submit if something happens, your Wi-Fi goes down, your computer crashes, power goes out, you lose Wi-Fi service, something like that happens. There is an now this week for you to be able to submit your solutions immediately after the test. And I think the key word there is immediately. So hopefully you'll get something, or you have already received something from the College Board. If you don't in the next day or so, let me know, and I'll make sure I'll get you more complete instructions, but make sure you read through that. It sounds like things are going pretty well, but it's a small percentage of students who are having technical difficulties, and so they're making arrangements for you to be able to submit your answer. And I don't think one of the options or one of the criteria would be, well, I just ran out of time. I still think they're expecting you to manage your time wisely. And when that 5-minute warning pops up on your screen, you got to stop right where you are and submit and get ready for the next question. With that being said, just make sure you read through that post I made yesterday, and I think we'll be fine there. Any last minute questions or any questions before we get started? I've got 2 questions for us to talk about today. And then hopefully it won't be a very extended class period today. But any questions before we get started? Okay, so the question I posed to you on Friday about schools receiving funding for attendance, and this is absolutely true. The better attendance we have, the more state funding we receive. Now, I don't know if this is the right ratio or the right numbers, but anyway, it's generally true that if you the more students you have on a daily basis, the more funding you receive. So anyway, the number of absences at the high school is normally distributed with a mean of 120 students and a standard deviation of 10.5. So the question is, if more than 140 students are absent on a particular day, the school will lose some of its state funding for the subsequent year. Approximately what is the probability that high school A will receive some state funding? Okay, so that one's pretty straightforward. This one really is just a matter of matching this value, 140 students on the normal curve. We're told the distribution is normal. So we're just going to follow that pattern. And I'm sitting here not presenting my screen, and you're all being quiet. You're thinking, Mr. Berry, what a dummy. So now we're in better shape, I think. So there we are. With the question on the screen. So what I'm going to do now, I'm going to go ahead and just kind of write this one out for you, because I want you to remember or to review or to see some important key factors in answering a question like this. I think by now, um, you guys are pretty confident about coming up with a solution for this. But the first thing you need to do, I started telling you about this on the first day. Draw that graph, and so the mean is at 120, and the standard deviation is 10 and a half. Another way you can do it is just normally distributed with a mean of 120 and a standard deviation of 10.5. That will completely describe your graph for you. You don't need anything else. And the point of interest that we're concerned about is 140, and we're concerned about if the attendance is greater than 140, so we want the right-hand tail. So very straightforward approach at this point. We're going to start out with a z-score. Z-score is going to be 140 minus 120 divided by 10.5. So we can calculate that pretty quickly. That's 20 divided by 10.5, so something around 1.9. So the z-score is 1.905 or 1.90. And so at this point we can go to table A if we wanted to. Let's see, let me pull up table A here real quickly. Okay, so this is table A that you'll be using on test day. So we're going to scroll down till we find a z-score of 1.90. So they made it really easy for us. And so the probability, and that z-score associated with 1.90.973 0.9713, but that is associated with the probability that z is less than 1.90. And so we want the probability that z is greater than 1.90. So we want the complement of that 1 minus 1.1 minus all of that, and I forgot the number. 1 minus 0.9713, 0.20087, 2087. Okay, so that's it. That's the probability that they will lose funding, about a 3% chance. And, if we were doing a significance test at the 5% significance level, we would reject that hypothesis, whatever it is. In this case, we don't have one, but if we had one, we would reject it. So pretty low chance that they're going to lose funding on a particular day, on any given day. So now let's look at the part B. That's not it. Part B here. There we go. Part B is, hey, you know what? We've got this better idea. We think you should choose 3 days at random throughout the year and see how that turns out. So if the mean of the 3 days is greater than 140, would high school A be more likely, less likely, or equally likely to lose funding? And so I'm gonna throw this one right back to you guys. And I'm just gonna ask you, what do you think about that? Is it more likely, less likely, or equally likely to lose funding if they pick 3 days at random? Anybody have an idea? Let me give you a hint. This goes back to our discussion of sampling distributions and what happens when we randomly select samples from a population that we know to be normally distributed. What do we know about the sampling distribution taken from that's created by those samples? If we were to take 1,000 or 100 samples, what would that sampling distribution look like? Okay, well, it's good we talked about this one then. Okay, so we know that the mean of X bar is just going to be equal to the mean of the population, which is going to be 120. And because we know the population is already normally distributed, it's given to us in the problem, we know that our sampling distribution will be normally distributed. We don't have to worry about central limit theorem or any of those other things. We know it's given, so we know that our sampling distribution will be normally distributed, and we know that the standard deviation of the sampling distribution is just going to be the standard deviation of the population divided by the square root of n. And in this case, we're going to take 3 samples. So the standard deviation was 10.5. We're going to divide that by the square root of 3. And so the standard deviation of the population is 10 divided by square root of 3, 5.77. Okay, so now we know that the sampling distribution is going to be more narrow than this distribution. So when I sketch it, or if I were to sketch it, if the sampling distribution is still going to be centered at 120, but it's going to be taller and narrower, and I'm not really good at that sketch, but it's normally distributed with a mean of 120 and a standard deviation now of we'll just call it 5.8. Okay. Well, if this is 5.8, then 140 is way out here, right? Because let's just call it 6. 3 times 6 would be 100. It would be 18, and I'm still more than 3 standard deviations out here. So the area under the tail out here is going to be really, really small. So from a qualitative standpoint, we can describe, we can show this graph. We can say that the area under the tail is going to be smaller than here, and so it is going to be less likely because the sampling distribution has less variation. The standard deviation is smaller. There's less variation. So the probability or the area under the tail out past 140 is going to be smaller. We can go ahead and calculate how much smaller. And in this case, what I'm going to do, I'm going to just refresh your memory on using the calculator to do this calculation. Um, uh, we will look at, let's see, second function distribution, and we want normal CDF here. So I'm going to hit 2. The lower boundary is going to be 140. Left boundary is going to be 140. My upper boundary is going to be a large number. The mean is 120. Oops, 120. Standard deviation 5.77. Plug that in, and it's a really, really, really small number. So let me get this back up here. Normal CDF with lower equal to 140, upper equal to 100,000, mean equal 120. And you want to make sure you go through this. You want to make sure you include these descriptions for these values. Don't just write 140, 10, 100,000, 120, and 5.77. Somehow you need to, in your response, make sure the reader knows you know what these values mean. And so that value was 0.002 something. What was it? 0.0026. We'll call it 264. And so you can tell this number is much less by a factor of 100, less than this one. So it is much less likely, and so we can calculate it there. You don't really, to get full credit for this particular question, you don't really have to give that mathematical description. It doesn't hurt. You can just use, like I said before, you can use a qualitative description describing that the sampling distribution has less variability. So therefore, the curve is much more narrow. The area under the curve past 140 is going to be less than. And that's really all they ask you for in that question is it going to be more likely, less likely, equally likely? And how you justify that is up to you. If you give a good description, like I just said, you'll be fine. But if you want to go through the computation here, there's no shame in that. There's nothing wrong with it. In fact, it's completely correct to do that. It won't hurt a thing. Either way is fine. So now let's look at part C. Of course, the high school week consists of Monday through Friday. The principal believes that absences will be worse on Monday and Friday. I guess this is a real party high school. Leave school early on Friday and not make it on Monday, kind of thing. He's wondering, okay, what's the probability that if school day is chosen at random, what's the probability that none of the 3 days is chosen is a Tuesday, Wednesday, or Thursday? And I think the hardest part about this question is just the wording where it says none of the days is Tuesday, Wednesday, or Thursday. So we immediately want to say, well, Tuesday, Wednesday, Thursday, that's 3 days out of 5. So the probability is 3 out of 5. But the question is that none of the days is Monday, Tuesday, or Wednesday. So really what we want to look at here is Come on back, screen. Where are you? I lost you. Come on. Well, what's happened to you, Mr. Image Mate? Oh, of course, you're not responding. Thank you. The wonders of technology. Okay, so let's just talk our way through this while that thing comes, while it gets cleaned off here. Now, I'll go back to it. HI, good grief. Now we're back. Okay. So part C, we want to find the probability that it is Tuesday, Wednesday, or Thursday, which is the same thing as the probability that it is Monday or Friday, which is 2 out of 5. Okay. So that's the first, that's the kind of the starting point here is if one day is chosen at random, what's the probability that it's not Tuesday, Wednesday, or Thursday? Well, that probability would be 2 out of 5, but we are going to pick 3 days, the 3 days at random. So basically, here's the trick. Since the, you need to make some statement about this, since the 3 days are randomly selected, the days are independent. And so what that allows us to do is to calculate 3 days, not Tuesday, Wednesday, or Thursday, is just simply going to be 2/5 cubed. If they were somehow dependent upon each other, our calculation is going to be a little bit difficult, a little bit more difficult here. But since they're randomly drawing them from a calendar, they're independent, and so we can just use there's no conditional probability here. We're just going to say it's 2/5 times 2/5 times 2/5. And that number is 4 cubed, 0.064. 0.064. So there's about a 6% chance that one of the 3 days will not be Tuesday, Wednesday, or Thursday. And so
but wouldn't the probability be different for every day you selected?
I'm sorry, say that again.
Like if you selected the first day, then like the next time you select another day, like one day is going to be gone. So it would
yeah, that's why I mentioned it's important to say that it's independent. Because if you were doing it without replacement, then it would not be independent. They would be dependent upon each other. But here the problem statement says that they are selected school day, if one school day is chosen at random from each of 3 typical school weeks.
okay.
What that means is the weeks are chosen independently of each other, and then you pick a day.
Okay.
So That gives us the independence. You're right. If we picked let's say the first week we picked Tuesday, and then we made the rule up that says, okay, the next week we pick can't be Tuesday, then they're not independent, and we have to go through a little bit more calculation. But that's important. That's the reason it's important. We say these are independent. If you were just to calculate that probability as 2/5 cubed without saying that it's specifically independent, that answer might go from essentially correct to partially correct. So always make sure you're describing your probability as being independent before you calculate it. Okay, good question, Briley. Any other questions? Again, none of those questions are particularly, I think, particularly hard. Certainly, we've covered everything. It's really now at this point in your preparation, it's just being able to focus in on what's the question asking and be able to get going pretty quickly. Again, let me remind you, you do not have to answer all parts of every question to score well. So if you get hung up on something, skip it. If in a minute or so you don't have a clear path to answering that question, skip it. Go on to the next question and see if you can go, pick up there, and maybe something will stimulate a thought, and you can always go back and finish it if there's time. But don't convince yourself that you have to answer all parts of all the questions to score well. Okay, so don't stress over that part. Okay. The next question is one we have not talked about for a while, and it's a sampling question. And I sent this to you already on Classroom. You may have had a chance to look at it or not. Some years I give this on the test. This year, I don't think y'all saw it on the test, but I really do like this question because it makes you think about what is cluster sampling and what is stratified random sampling. And so I really, again, like I said, I really do, I do value this question, and I think it's important that at this point we go over it. So an apartment building has 9 floors, and each floor has 4 apartments, and you can kind of see the layout of the apartments here. There's an apartment in each of the 4 corners. So basically the floor is divided into quadrants. My guess is there's an elevator lobby somewhere in the middle, and a hallway leading down to each of the apartments somehow. I'm not really sure, but that's not really important for us right now. All we need to know is that there are 9 floors, and there are 4 apartments on each floor. Now, the only other important characteristic is that some of the apartments have children in them. So apartment number 11 on the first floor, 22, 23 on the second floor, none on the third floor, etc. And so the apartment manager wants to survey the apartment, or I think he wants to try out, or she wants to try out a new style carpet, I think. Yeah, she wants to try it out in 8 of the 36 apartments before she replaces the carpet in all of them. So, and when we talked about sampling procedures, we said that cluster sampling is probably the most convenient sampling technique we have. Because if you remember what cluster sampling is is you divide the population into heterogeneous groups where they're all about the same. And it tells you that the floor is the cluster. So this is a cluster, that's a cluster. When you do cluster sampling, the random element comes from the fact that you randomly choose a floor. Okay. And then you're going to sample all the rooms on each floor. So you're going to randomly select a floor, and then all 4 apartments in that on that floor would get new carpet. And in order to get 8 different apartments, she's just going to pick 2 floors at random. So what we need to do here is to describe a process for randomly selecting 8 different apartments. So anybody want to give that a whirl? Any suggestions? I'll pretend to be thirsty while you.
Like what kind of sampling thing we would do?
Yeah, how would you conduct for part A? Describe a process for using cluster samples to select 8 different apartments.
Is it?
Don't make this too hard. Think about the ways that we did random selection
the
before.
stratified thing, isn't that one?
Well, stratified is one, and we're going to talk about that in part B. Now we're talking about a cluster.
Oh.
So that means a cluster sample means we're going to randomly select the floor. So really what I need right now is a process for randomly selecting 2 floors out of a 9-story building. And
roll 2 dice and ignore the 10, 11, and 12.
Okay. Yep.
Or a random digit table.
Oh, you mean like that?
Yeah. Yeah. Don't make it too hard, Gracie. Don't overthink this. So I was just going to say, what kind of ways did we use to randomly select things? We rolled dice. We drew cards. We took the cards out of a deck. We used a random digits table. You can use a random number generator on your calculator. Or in my view, the simplest one for this one is just draw numbers out of a hat. Briley has a great idea. We need a number. We need the numbers 1 through 9. And most people aren't nerdy like me and have a 10-sided die. So you're gonna be stuck with a 2 6-sided die. Almost everybody has that. So you roll the die and you just ignore the result 10, 11, and 12. You pick the number that comes up. If you get a number to ignore, you skip it. You roll again. And so that gives you your first floor. Your second floor is the same process. Roll the 2 6-sided die. If it's a number 1 through 9 that wasn't selected before, you keep it, and those are your 2 floors. If it's a number 10, 11, and 12, you skip it and you roll again. You've got your 2 floors, and then you will put new carpet in each of the 4 apartments on those floors. Now, you could use a random digits table. Numbers 1 through 9 represent the floors. You'll skip 0. Randomly select a line on the digits table, and you go till you get an apartment number. And on a random digits table, you know what? This thing doesn't give you. They don't give you a random digits table on here, do they? Huh. Well, there's a hint. if you have to use a random digits table, they'll probably give you the portion of it. And in this case, to fully answer the question, you don't have to write out line 107 and give the 50 numbers across the table. You can just say, I'm going to use a random digits table. Choose 1 through 9. Let numbers 1 through 9 represent the floors. Ignore a 0. Randomly pick a line number, and then pick the first 2 unique numbers that come up, and those are your floors. That's a perfect description. Now, I know you're trying to write maybe or jot down some notes as I'm talking, and so what I'll do after this is I'll jot down a summary response that is sufficient for this question, just so that you can see what the reader is expecting to see, and I'll send that along to you. So that's part A, cluster sampling. Randomly choose one of the floors and then put new carpet in all the floors. And remember my example of cluster sampling in class was the health inspector checking the salads at a restaurant. The salads are all pre-made on a plate, and they're just sitting in a refrigerator ready to be pulled out and taken to the table. And so the health inspector randomly selects plates from the refrigerator, pulls the plate out, and inspects everything on the plate. That's a cluster sample. Okay. Now, part B is, okay, so another way to do this would be a stratified sample, where the strata are apartments with children and apartments without children. Okay, so now we have a little bit different task in front of us, because what we want is 8 apartments. We still want 8 apartments. And the question is, stratified sample of 8 apartments could include 2 apartments randomly selected with children and 6 randomly selected with no children. Give one statistical advantage of using stratified sampling as opposed to cluster sampling. So I say this to Gracie: read the question and just answer what they ask. Don't come up with a stratified sampling technique. That's not what they ask. All they ask here is one advantage for selecting stratified over cluster. And there's one glaring advantage of using that technique. And what is it?
You can see how the floors work with kids or not kids.
Well, yeah. The thing about it is, if you choose cluster sampling, how many floors are there without kids? 1, 2, 3 of the 9 floors have no kids. Is that right?
Uh-huh.
Or let's look at it a different way. Yeah, 3 of the 9 floors are without kids. So there's a 1 in 3 chance that you'll get both of your samples without kids, roughly 1 in 3, because it's not independent, but roughly 1 in 3. So with a stratified sample, you're guaranteed to get at least 2 of the floors. Get at least 2 of the apartments with kids. Now, you don't know what apartment it is, 11, 22, 23, whatever. But the advantage is, with stratified sampling, you're guaranteed to test the new carpet in apartments with kids and some apartments without kids. And so that's the advantage, is that there is a risk, and it's a pretty big risk, that you'll that with cluster sampling that you'll miss apartments with kids. So the advantage of stratified sampling is that you're guaranteed to get 2 apartments with kids in there. And so you'll be able to compare how well does it wear with kids versus without. And that's it. That's the main thing they want you to see, is that there is a possibility with cluster sampling. There's a possibility you could pick the 3rd and the 6th, or the 3rd and the 4th, or the 4th and the 6th, and not get any kids on your carpet. Okay. So part B, the question that's asked isn't hard. If they had asked, describe a process for doing a stratified random sample, then you're really going to have to think about that one. And honestly, I would come down to, I mean, you could use a random digits table and ignore all of the non-apartment number digits of 2 digits, ignore 15 through 19 or 15 through 20 and etc. If I were doing it, I would just say we're gonna put the in a hat, and we're told we're gonna draw 2 out, so we're gonna put the numbers 11, 23, 22, 51, 73, 74, 84. We're gonna put those numbers in a hat, draw 2 of them out. And those would be our 2 randomly selected apartments with children. Put the other numbers in a hat and draw 6 of them out. And those would be our 6 randomly selected non-children apartments. But that's not what the question asked. And so really the important thing here is really, and the reason I picked this question is just so that I could refresh your memories about cluster sampling and stratified random sampling. Okay. Questions here? All good? All righty. I will post a solution to both of these here in a little bit. And I think I will, there's another really good stratified random sampling question, free response question that I can think of. I'll pull it out of the folder and throw that one at you to read over and look at. We'll talk about it tomorrow. Okay. Now let me ask the group. We've got really Tuesday and Wednesday to, are there any particular topics that you want me to go back over? And the best way I know to show you the topics really is, here are the chapter titles that we've covered in class. Chapter 1, exploring data, that was just using graphs. Chapter 2, modeling, that was learning to use the normal distribution or the standard normal table and normal distribution, describing relationships. That's what we just did in terms of creating scatter plots and linear regression. Designing studies, that is sampling plans, simple random samples, stratified sample, and cluster sample, as well as experiments, completely randomized, block design, and then when the blocks are size 2, that's called the term has left it's right on the tip of my tongue, a binary sample. And then random probability and random variables. Those are things that we talked about more recently. Random variables, discrete random variables, and then continuous. The one continuous one we talked about was binomial, sampling distributions, sampling with confidence, and testing a claim. Those are things that we've all talked about, or all those things we've talked about since spring break and since then. So hopefully that's fresh in your mind. Those topics jump out at you and say, "Hey, I want to see another question from there." If nothing jumps out at you, I'll pick some. We'll probably go back and look at reading some charts. They're really good at throwing graphs at you that are sometimes hard to read. So we'll go back and pick one of those. And I don't know. There are lots of good questions we can pick from, but everything I'm going to pull out is just an old free response question from before. Okay. Any questions? All right, gang. I will see you tomorrow. Y'all have a great day.
Bye.
Oh, by the way, your grades are posted. You're welcome to look. All of you did really well. I'm proud of you. All right. Okay. Well, we'll see you tomorrow.
Bye.
Bye.